Geoenergy and exhaust air heat recovery is an energy-efficient form of heating. It utilises the renewable heat in bedrock. The heat from indoor air leaving a building can also be recovered. A heat pump system is needed to utilise the heat. The system's central components are a heat pump, a hot water tank, and a buffer tank. The cold heat transfer fluid will travel from the heat pump to the heat collection circuit. The heat collection liquid is an environmentally safe mixture of water and alcohol. This heat recovery circuit includes exhaust air heat recovery, as well as a collection well and 3 energy wells. The energy wells are spread as far apart on the plot as possible. Their depth and number will be determined based on the heat energy needed. The heat stored in the ground and bedrock will transfer to the heat transfer fluid in the energy well. The heated fluid will then return to the heat pump via a collection well. From the heat pump, the cool heat transfer fluid will also travel to the roof-mounted heat recovery unit. The fluid travels in an insulated line that has been installed on the building's facade or stairway. The warm indoor air will travel through the heat recovery unit's heat exchanger. This transfers heat from the air to the heat transfer fluid. The air cools down and exits the building, and the warm fluid returns to the heat pump. An efficient process occurs in the heat pump. The heat recovered by the heat transfer fluid will transfer to the building's heating water and warm household water. The process generates 3 or 4 times the heat energy in comparison to the electricity used. From the heat pump, the water used for heating the building travels to the buffer tank. Warm water is constantly cycled to the radiator network from the buffer tank. The warm water travels to the apartments and warms the indoor air through the hot water radiators. When the water cools down, it returns to the heat pump. The hot water tank is connected to the cold water supply. The supplied cold water will warm up when it comes into contact with the hot water, heated by the heat pump in the tank's heat exchanger. The warm water is supplied to the residents. The heat pump provides the tank with heating water when necessary, and cool water that has transferred its heat returns to the heat pump. The hot water tank size is based on the number of apartments and the demand for warm household water. When a building is equipped with both geothermal heat and exhaust air heat recovery, not all heat from exhaust air is always needed for heating, especially not in summer. The excess heat can then be charged into the energy wells. In the heat recovery unit, the heat of indoor air will transfer to the heat transfer fluid. The heat transfer fluid then flows into the energy wells through the heat recovery circuit's pipes. In the energy well, the heat transfer fluid transfers the indoor air heat into the bedrock surrounding the energy well. The heat stored in the bedrock can then be used during the next heating season. The now cool heat transfer fluid travels to the collection well and then returns to the roof-mounted heat recovery unit.